When dealing with water pipes that have ground connections, it's crucial to safely determine if electrical current is flowing through them. This is particularly relevant when changing water meters to avoid potential electrical hazards. There are methods to detect current flow in both non-visible and visible ground situations. For non-visible grounds, you can use a non-contact alternating current direct current voltage detector. Scan the surface of the water pipe near the suspected ground connection. If current is flowing, the detector will typically light up or beep, indicating the presence of voltage. Alternatively, employ a non-inductive clamp meter. Clamp the meter around the water pipe to measure the current flowing through it. This method provides a direct reading of the amperage in the pipe. When dealing with visible grounds, use a contact voltage detector, which is often a test light. Touch both terminals of the ground wire and the water pipe. If current is flowing, the test light will illuminate. A non-inductive clamp meter can also be used on a visible ground. Clamp the meter around the ground wire to directly measure the current flowing through it. Regardless of the method used, several precautions must be taken. Always use appropriate personal protective equipment, including insulated gloves and non-conductive footwear. Never make direct contact with the ground conductor or the water pipe without proper protection. Always check for voltage before touching any electrical components or making any adjustments. It's important to determine the source of the electrical current before taking any further action. If the current is originating from an electrical device or a faulty wire within the residence, it may require a licensed electrician to resolve the issue. Ignoring the current source may lead to further complications or hazards. Safety should always be the top priority when working with electrical systems. When using any type of electrical meter, it is important to follow the manufacturer's instructions carefully. Ensure that the meter is properly calibrated and in good working condition before use. Prior to any testing, visually inspect the water pipe and surrounding area for any signs of damage, corrosion, or water leaks. These conditions can affect the accuracy of your measurements and increase the risk of electrical shock. When using a non-contact voltage detector, slowly move the detector along the surface of the water pipe, paying close attention to any changes in the detector's readings. A sudden increase in the detected voltage may indicate a point where current is entering or leaving the pipe. When using a clamp meter, ensure that the jaws of the meter are fully closed around the pipe or ground wire to obtain an accurate reading. Avoid clamping the meter around multiple conductors at once, as this can lead to inaccurate measurements. If you detect any current flowing through the water pipe, do not attempt to repair or modify the electrical system yourself. Contact a licensed electrician to investigate the source of the current and make any necessary repairs. Remember that electrical work can be dangerous, and it is always best to leave it to the professionals. If the water pipe is located in a damp or wet environment, take extra precautions to prevent electrical shock. Wear rubber boots and avoid touching any grounded metal objects while working. If you are unsure about any aspect of the testing procedure, consult with a qualified electrician or electrical engineer. They can provide you with guidance and assistance to ensure that you are performing the test safely and accurately. Regularly inspect your electrical tools and equipment for any signs of damage or wear. Replace any damaged tools or equipment immediately to prevent accidents. When working with electricity, always be aware of your surroundings and take steps to minimize the risk of electrical shock. This includes keeping a safe distance from energized equipment and avoiding contact with water or other conductive materials. Finally, remember that electrical codes and regulations vary depending on your location. Be sure to familiarize yourself with the local codes and regulations before performing any electrical work. If you are not sure about the applicable codes and regulations, consult with a local electrical inspector or code official. By following these safety guidelines and using the appropriate testing methods, you can safely and effectively detect electrical current flowing through grounded water pipes. This will help to ensure the safety of yourself, your colleagues, and the public. Understanding the potential risks associated with grounded water pipes is essential for anyone working with plumbing or electrical systems. Grounding water pipes was a common practice in the past to provide a path for electrical current in the event of a fault. However, this practice can create hazards if the electrical system is not properly maintained or if there are problems with the grounding system. In some cases, the water pipe may become energized, posing a risk of electrical shock to anyone who comes into contact with it. This is especially true if the water pipe is located in a damp or wet environment. One of the most common causes of current flow in water pipes is a faulty appliance or electrical device. If an appliance has a short circuit or other electrical problem, current may flow through the grounding wire and into the water pipe. This can energize the water pipe and create a shock hazard. Another potential cause of current flow in water pipes is a problem with the electrical grounding system. If the grounding system is not properly installed or maintained, it may not provide a low resistance path for electrical current. This can cause current to flow through other conductive paths, such as water pipes. In addition to the risk of electrical shock, current flow in water pipes can also cause corrosion. Electrical current can accelerate the corrosion process, leading to leaks and other problems with the water pipe. To prevent these problems, it is important to have your electrical system inspected regularly by a qualified electrician. The electrician can identify any potential problems with the grounding system or electrical devices and make any necessary repairs. It is also important to avoid using water pipes as a grounding electrode for electrical equipment. This practice can create a dangerous situation if the electrical system is not properly maintained. If you suspect that there is current flowing through your water pipes, contact a licensed electrician immediately. Do not attempt to repair or modify the electrical system yourself. Electrical work can be dangerous, and it is always best to leave it to the professionals. By taking these precautions, you can help to ensure the safety of yourself and your family. The electricity always seeks the path of least resistance. If the intended grounding path isn't optimal, the current might choose the water pipe as an alternative route back to the source. This is particularly dangerous as water pipes are often accessible and can pose a shock hazard. There are several reasons why a water pipe might become part of the electrical circuit. Firstly, improper wiring or faulty appliances can cause current leakage, which finds its way to ground through the water pipe. Secondly, corrosion or loose connections in the grounding system can increase resistance, diverting current through the water pipe. Thirdly, outdated or non-compliant electrical installations may not have adequate grounding, making the water pipe a convenient path for stray current. Water pipes, being metallic and continuous, can conduct electricity efficiently. However, this conductivity also makes them a potential shock hazard. If a person touches an energized water pipe while in contact with a grounded object, such as a wet floor or another appliance, they could complete the circuit and experience an electrical shock. The severity of the shock depends on the amount of current flowing through the pipe and the person's resistance. Even a small amount of current can cause a painful shock, while higher currents can be fatal. To prevent electrical hazards associated with grounded water pipes, it's crucial to ensure that the electrical system is properly grounded. This involves having a dedicated grounding electrode, such as a ground rod or a metal water pipe that's directly connected to the earth. The grounding electrode provides a low resistance path for fault current, allowing it to flow safely back to the source and trip the circuit breaker. It's also essential to inspect the grounding system regularly for corrosion, loose connections, or other damage. Any problems should be addressed promptly by a qualified electrician. In addition to proper grounding, ground fault circuit interrupters, or GFCIs, can provide an extra layer of protection. GFCIs are designed to detect even small amounts of current leakage and quickly shut off the power before a shock can occur. GFCIs are typically required in areas where water is present, such as bathrooms, kitchens, and outdoor outlets. If you suspect that there is current flowing through your water pipes, it's important to take immediate action. Firstly, avoid touching the water pipes or any metal objects that are in contact with them. Secondly, call a licensed electrician to investigate the problem and make any necessary repairs. Thirdly, if you experience any electrical shocks while using water, turn off the main power supply to your home and call for professional help. Electrical safety should always be a top priority. By understanding the risks associated with grounded water pipes and taking the necessary precautions, you can protect yourself and your family from electrical hazards. Remember, electricity is a powerful force that should be treated with respect. Improper handling of electrical systems can have serious consequences. Therefore, it's always best to rely on qualified professionals for any electrical work. Now let's discuss the tools and techniques in greater detail. The non-contact voltage detector, also known as a voltage tester, is a handheld device that can detect the presence of alternating current voltage without making direct contact with the conductor. It works by sensing the electric field that surrounds energized conductors. When the detector is brought near an energized water pipe or ground wire, it will emit a visual or audible signal indicating the presence of voltage. The non-inductive clamp meter, also known as a clamp-on-ammeter, is a device that can measure the current flowing through a conductor without breaking the circuit. It works by clamping around the conductor and measuring the magnetic field that is produced by the current. The meter then converts the magnetic field measurement into an amperage reading. A contact voltage detector, also known as a test light, is a simple device that can be used to check for the presence of voltage. It consists of a small light bulb or LED that is connected to two test leads. When the test leads are touched to an energized conductor on a ground, the light will illuminate, indicating the presence of voltage. When using any of these tools, it's important to follow the manufacturer's instructions carefully. Always wear appropriate personal protective equipment, such as insulated gloves and safety glasses. And never work on electrical systems while they are energized. To determine the source of the electrical current, you may need to trace the wiring back to the electrical panel. Look for any loose connections, damaged wires, or faulty appliances. If you find any problems, contact a licensed electrician to make the necessary repairs. In some cases, the electrical current may be coming from a neighboring property. If this is the case, you will need to contact the utility company to investigate the problem. Electrical current in water pipes can also be caused by galvanic corrosion. Galvanic corrosion occurs when two dissimilar metals are in contact with each other in the presence of an electrolyte, such as water. The more active metal will corrode, while the less active metal will be protected. If a water pipe is made of a different metal than the grounding electrode, galvanic corrosion can occur. This can cause the water pipe to corrode and eventually leak. To prevent galvanic corrosion, it's important to use compatible metals for the water pipe and grounding electrode. You can also use a dielectric union to isolate the two metals from each other. A dielectric union is a fitting that is made of a non-conductive material, such as plastic. It is used to separate two dissimilar metals and prevent galvanic corrosion. In addition to galvanic corrosion, stray current can also cause corrosion in water pipes. Stray current is electrical current that is flowing through unintended paths, such as water pipes. Stray current can be caused by a variety of factors, including faulty wiring, electrical equipment, and underground power cables. To prevent stray current corrosion, it's important to ensure that the electrical system is properly grounded and that there are no stray current sources. You can also use cathodic protection to protect water pipes from corrosion. Cathodic protection is a technique that uses an external power source to apply a negative electrical charge to the water pipe. This negative charge protects the water pipe from corrosion. There are two main types of cathodic protection, namely impressed current cathodic protection and galvanic cathodic protection. Impressed current cathodic protection uses an external power source to supply the protective current. Galvanic cathodic protection uses a sacrificial anode, which is a metal that is more active than the water pipe. The sacrificial anode corrodes instead of the water pipe. The choice of cathodic protection system depends on the specific application and the environment. In general, impressed current cathodic protection is used for larger structures such as pipelines and storage tanks, while galvanic cathodic protection is used for smaller structures such as water heaters and underground pipes. Electrical hazards can also be present when working with underground water pipes. Underground water pipes can be energized by nearby power cables or by stray current. To prevent electrical shock when working with underground water pipes, it's important to call the utility company to locate any underground utilities before digging. You should also use insulated tools and wear insulated gloves and footwear. And never work on underground water pipes while they are energized. If you are unsure about any aspect of working with electrical systems or water pipes, consult with a qualified electrician or plumbing contractor. They can provide you with guidance and assistance to ensure that you are performing the work safely and correctly. Remember, safety should always be your top priority when working with electricity and water pipes. By following the proper procedures and taking the necessary precautions, you can protect yourself and others from electrical hazards. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified professional before performing any electrical work or working with water pipes.